Oh, algae. Isn't it beautiful? I mean, look at it. Sometimes it is. Algae has been around for many millions of years, yet you can still find them growing in your aquarium. And I think it's the most heartbreaking and nerve-wracking enemy of many hobbyists. These tiny organisms may take over your tank and possibly make you want to scream your lungs out, if not quit the hobby. The idea of restarting your tank may seem less laborious than trying to bring your tank back to its glorious first days. So, what is algae? Algae are a group of aquatic, non-flowering plants which include seaweeds and single-cell species. In the hobby, we tend to categorize algae according to their phenotype, which is how they look, and not according to their species. So generally, we have blackbeard algae, hair algae, green spot algae, and so on. A different type of algae is blue-green algae, which is aquatic cyanobacteria, and brown algae, which are diatoms. It doesn't matter what kind of algae you have, this guide will help you combat algae regardless the type. Algecides such as copper have been used in the hobby for quite a while. However, it is impossible to determine the correct dose that will not damage your livestock or your plants. The difficulty in eradicating algae is that algae and plants share many characteristics, meaning that it's very hard to find a plant-safe measure. Copper is well known to be highly toxic for shrimps and snails too. So, if you plan on keeping any of them, it's definitely a no-go. Bleaching agents and peroxide have been used to spot bomb algae. Now, the damage that will be caused to plants is difficult to predict. If you might have seen my first days of the setup, I had used Monte Carlo as a carpeting plant. However, while spot bombing a couple of hydras, the peroxide sank to the bottom, burning all of my Monte Carlo except for a tiny corner. The last measure which most people suggest is light reduction. Now this is a no-brainer because algae are usually shade plants, meaning they do not need a lot of light. Not that high light intensity will kill them. Low light, on the other hand, will stunt your live plants. And if you have a dirted tank, your whole tank relies on plants, so killing them will not be a good idea. Also keep in mind that algae can adapt to different light conditions as to different wavelengths of light, so changing your light to combat algae will not be beneficial in most cases. Generous water changes are usually given as an advice on most Facebook groups I am in. However, there is no evidence supporting this action. I can only see that it might work in aquariums where you might have accidentally overdosed some kind of fertilizer, but other than that, I don't think it will work. I have stumbled upon the internet for controlling measures for blue-green algae, and one of them is to remove as much of it as possible. Now, that doesn't really make any sense to me, and I will tell you why. In medicine, we learned that a disinfecting agent is considered good when there is at least a cleaning potency of 99.99% or more. Most products, however, claim to be killing 99.9% of bacteria, meaning 1 in 1,000 is left behind. Now let's see how many divisions away is 1,000 from one single cell. The 1 will give 2, which will give 4, which will give 8, 16, 32, and you see how it goes on. That's a total of 10 divisions, and one of the fastest growing bacteria divides every 20 minutes, which means that you have around 200 minutes, which is 3.5 hours roughly. So the surface you wiped clean is dirty again, huh? So, algae may not be that fast growing, but it's not that water changes or manual removal is going to achieve a 99.9 clear up. By the way, You also learned that spending a lot of money on cleaning agents with a 99.9 disinfection rate is not probably worth the price. Keep in mind that generous water changes may be protective if your tank is seriously infested with green water algae, because you may not want a large mass of dead algae in your aquarium. Last but not least, try keeping phosphates low is impossible. Natural waters contain 0.003 to 0.02 parts per million of phosphates, which reduces algae's ability to grow. However, aquarium levels typically have over 1 part per million, which is enough for algae to grow. Since phosphate is in fish food, you cannot practically prevent it from entering the aquarium in the first place. Keeping phosphates under 0.02 parts per million is practically impossible. So let's talk about methods that might work. Here I will talk about two methods, one that I find useful and one which is controversial. Keeping shrimp, snails, or algae-eating fish may be beneficial, especially for the first days. However, keep in mind that this is only a measure that will clear up the algae until you find a more permanent measure, because less tasty algae will develop at some point and no shrimp, snail, or fish will eat it. Another measure I have found around is the use of liquid carbon, the most common of them being sea Chemphloris XL. Now, there's a lot of mixed up info about it on the internet. One thing is for sure, it's not liquid carbon dioxide. It is organic molecules that will eventually break down to carbon dioxide. There have been reports of it being used as an algicide, however, it's not advertised as one. Also, there have been some anecdotal reports that some plants such as Egeria densa or hornwort will show signs of melting in distress when it's been used, especially at higher doses. If you want to, go ahead and try it, but this video is more about a natural approach, which I will analyze in a minute. Now, why is it so common to suggest light reduction if algae are shade organisms? It's because light increases iron's bioavailability by a method called iron photoreduction. Iron is bound to the substrate and in dissolved organic molecules in the water column. Also, it can also be bound to binding agents such as EDTA, which comes in many water conditioners. Bound iron is not available for metabolism. However, light will increase its bioavailability, and algae need iron to develop. That's why light can cause algae outbreaks. By the way, another extra tip is keeping your light schedule 5-4-5. Keep your lights on for 5 hours, turn them off for 4, and then turn them back on for 5. That will give plenty of time for the tank to refresh carbon dioxide, whereas algae is proven to be a little slow starter regarding photosynthesis, whereas plants will start photosynthesizing right away. Since iron is mostly found in the substrate, if your tank is receiving intense light from the sides, you may have some algae problems. This is usually countermeasured by adding some duct tape on the outer side of the tank along the background. This will keep off light and reduce iron's availability for algae. Also, keeping dirt as a substrate will do most of the job for you. Dirt is full of minerals such as iron and phosphates, and you will not have to worry about adding micronutrients. Also, dirt is one of the best substrates for plant growth, meaning that a healthy root system will outcompete algae at some point. It's not only the competition for nutrient, but plants will also secrete compounds which will keep algae and cyanobacteria to low levels, meaning that plants themselves have some algacidal and antibacterial properties. Emergent plants and surface plants are not limited by the low carbon dioxide levels in the aquarium. This means they are growing faster when compared to algae and will deplete the water of important nutrients such as iron. A healthy plant growth will outcompete algae, and most of the time your aquarium will not require anything more. That's why I love floating plants such as duckweed. It's fast growing, it will outcompete most of algae, and it is much easier to deal with when compared to algae. I mean, you just take a fork and thin it out. So let's say you have done everything by the book, but still you have some issues with algae, or for no reason you see unexpected rampant algae growth. So these are some steps that you could follow and maybe see some results. You can try reducing light if your tank is getting sunlight. Maybe the substrate taping will work. Finally, check your lights. If you think you have gone a bit too far with the light, keep a more natural or warm light instead of a cool light. Blue penetrates easily to the bottom of the tank, and because it's a higher energy beam, it's doing a better job in making iron available via photoreduction. Additional to that, if pH is high, which is more than 8, that means algae will have an advantage over your plants. You can try to add some hard water plants in your aquarium, such as hornwort. Or try reducing the pH by adding some driftwood or by adding vinegar in your aquarium. Keep in mind that you should not use more than 1 milliliter per gallon of water. This will give your plants a head start and restore the balance. Don't think the vinegar is a measure that will help you get rid of algae once and for all. It will just help you fix the pH for a while until the plants do their job. Finally, do a water change and add organic carbon in your filter. This will remove all of the dissolved organic compounds that carry iron and will also protect your tank from dying algae. Keep in mind that a massive algae eradication can cause imbalances to your nitrogen cycle, deplete your tank of oxygen, and it can cause the release of toxins, which can damage and possibly kill your livestock. I hope all of the above steps help you, and if you enjoyed this video, don't forget to check my other videos as well. Your likes, your comments, and your subscriptions really motivate me, especially now that I'm starting on YouTube. If you have any topic that you would like to hear of, then just leave it in the comment section below. Have a nice day and happy fish keeping!